Now you just need to know. Alright, so very first thing should be the first page. You should have the box filled in. Okay? Right? Okay? So make sure that the box is filled in. From my observations on Thursday, of my 2 classes on Thursday, numbers 1 and numbers 2 were the easy section. So that's why we're going to start with those. Okay? So in section number 1, we were basically promoting the fact that the sine value and the cosine value has to be between -1 and +1. Because on the unit circle, now I can flip this unit circle back around. On the unit circle, the maximum value that you can ever be is 1 unit away from the origin. Because it's got a radius of 1. Okay? So the most you can be is -1, or sorry, the least you can be is -1. Most you can be +1 horizontally. Okay. Now, what this means to you is if we ask what's the sine value of angle T, and you fire back with 7.4, can that be legal? Gotta be in between 1 and -1. Okay? So if you get a value when you're doing maths later on, when you're doing the trigs, and we're solving equations and all that fun stuff with trigonometry and all that great stuff that we're going to get into, and you get an answer that says sine of t is equal to 4, you're wrong. Okay? Because it's got to be in between -1 and +1. Okay? All right? So that was number 1. And in my classes, at least on Thursday, people whipped through that in no time. Like it was go time, and you guys picked up on that. Any questions on that right now? Okay, love it. Okay. Then section 2 was all about the hammer. Now we call it the hammer because it's the tool that builds. Okay. If you've ever been around a construction site or you've ever been building a project at home, it's the tool that builds. It's the first thing you grab on the toolbox is the hammer. Okay? If not just a beat on some parts that you are frustrated with. Okay? But it still is the first one. Okay? So the unit circle equation was x squared plus y squared equals 1. Okay? Circle, centered at the origin, radius of 1. But then we said that cosine of t was x, sine of t was y. So then we said that the hammer is cosine squared, and that's how we write cosine squared or higher powers of trig functions, is this line right above what the words the hammer. Okay? Cosine squared of t plus sine squared of t. Then we went through and we utilized this. Okay? And we said, okay, we can handle this, not a big deal. We've got the hammer, cosine squared plus sine squared equals 1. It's where it's going to be our starting point for a lot of problems. Okay? We know that the cosine is 1/2, so we plugged in 1/2 for cosine. Well, 1/2 squared is 1/4. So that's where we got this line right here, 1/4 plus sine squared. And then we said to ourselves, well, I solved that. We can subtract 4. 1 minus 1/4 is 3/4. So we got sine squared equals 3/4. Okay? Then this is where we got a little screwed up in my 2 classes on Thursday. Because people just left the fraction inside the radical. Which is mathematically fine. I got no problems with it. But when one of those, either the numerator or the denominator, is a perfect square, then we can simplify it. Okay, so then this is really, right here, this is really plus or minus the square root of 3 over the square root of 4. When we take the radical of a fraction, we take the radical of the top of the radical. Okay? And that's where we got plus or minus square root of 3. All right? Now, the question is, why is the sign both positive and negative there? Or those two possible answers? And the reason for that is cosine is 1/2. Well, that happens here at pi over 3. Yes? Okay. But it also happens down here at 5 pi over 3, where cosine is again positive 1/2. It happens in both locations. We didn't give any more conditions. Later on this week, we'll give you a second condition that will narrow it down to 1 trig value. Okay? But for now, we have to be open to both of them because we don't have that extra condition. Okay? Then we went on and we had you do one on your own. Okay? So we said that the sine of t was 5 over 6. And you should have figured out the fact that the cosine then would be plus or minus the square root of 11 over 6. But more importantly, we figured out that on the unit circle, sine is positive top half, cosine is positive right half. Tangent is positive quadrants 1 and 3. Well, tangent is positive on the in the diagonal, so that's why we didn't include that one. Okay? I would extend that, and I would also say that if cosine is positive on the right half, that secant is also positive on the right half. And if sine is positive on the top half, that cosecant is also positive on the top half. Okay? Any questions on number 2, the hammer? Okay. Again, I thought that we got through those two fairly well. Okay? Then we hit a roadblock. We got to number 3 on Thursday in both of my classes, and people's heads started smoking. Okay? Because their brains were working harder. Okay? All right? So what this is saying, okay, what we're saying with RAP values greater than 2 pi, what's being said there is this. Okay? So we've got this point right here, T. The only spot on the unit circle where everything is the same is right back at T. Okay? We can go down here. We can go down there, and 2/3 of the thing, actually I like 1/3 of the trig values would be the same. Only cosine and secant would be the same. We can go over here, and only sine, and sine and cosecant would be the same there. And we can go here, and only the tangent and cotangent would be the same. Okay? So the only spot on this whole circle that has the same trig values for everything, come on, is right there. Okay? It's just at T. So we have to get back to T. Well, that means we have to go a complete extra revolution in either direction. Either in the positive direction or in the negative direction. Okay? But if we make a full revolution, we end up back at the exact same spot. The difference is the angle that we are talking about. Okay? We're physically at the exact same spot. It just took us a different angle measurement to get there. Okay? And that was what the point of this was, is number 4, was the fact that as long as we are in even pi multiples away, we have the exact same trig value. Okay? So if this happens to be pi over 6, that would have the same trig values as 13 pi over 6. That would have the same trig values as 25 pi over 6. That would have the same trig values as negative 11 pi over 6. That would have the same trig values as negative 23 pi over 6. And so on and so forth. As long as we're always 2 pi away in terms of the degree or the radian measure. If we were dealing with degrees, we would add and subtract 360 degrees there. But we would get back to the exact same spot. Any questions on that? That cleared that one up a little bit? What else do we have on that page? Oh, and then on that page we had all of these. Yeah. Okay. So these were the answers that we were looking for at the bottom of that. Okay? Some people were trying to give me like these answers right here. They're trying to give me this right there as the answer. I'm like, whoa, 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 tap the brakes. That's just getting you to that spot on the unit circle. Okay? All right? So the sine of 10 pi over 3, 10 pi over 3 is bigger than, it's not on the unit circle. I should say, not bigger. It's just not on the unit circle, as written. Okay? So a full lap in terms of over 3s, or 2 pi over 3, if you will, is 6 pi over 3. So 10 pi over 3 is 6 pi over 3 plus 4 pi over 3. This one gets you a little, you got to think a little bit about this because it's fractions and you're not used to using fractions. Okay? But a lot of trig is fractions. Okay? So really, this is the sine of 4 pi over 3 is what's going on there. So then we go to 4 pi over 3 and we look for the sine of it, and the sine of it is negative square root 3 over 2. And so on and so forth. Does anybody have any questions or want me to walk through any of them, J, H, I, J, K? The rest of the 5 on this page. I. Okay. So cosecant of negative 8 pi over 3. Okay. So negative 8 pi over 3 is still bigger because remember, one full lap in the over 3s is 6, either positive or negative. Okay. So really, this is, so the way that I did this one here was I added 12 pi over 3 because that's 2 laps and it gets me to a positive trig value. Okay? I mean, I could have just said here, negative 8 pi over 3 is 6 pi, if I negative 6 pi over 3 plus negative 2 pi over 3. With me? Because that gets And then I can start at 0, and I can go back 2 pi over 3's. 1, 2 pi over 3's. Okay? Or I could add another lap and then in positive. Okay? One of the two, either way. So that's how I got this to be the cosecant of 4 pi over 3. Okay? Which is also the cosecant of negative 2 pi over 3. Which is also the cosecant of negative 8. Okay? All of them are in the exact same spot because they're all of those three angles are 2 pi radians. Okay? And so then it just happens to be, okay, so cosecant is 1 over sine. 1 over sine, so that would be the reciprocal of this. So that's why it's negative 2 over the square root of 3. But rationalized, then it would be negative 2 square roots of 3 over. Okay. Clear as mud. Any other ones from this page? No? All good? Okay. So then we said on number 5, what if we only go halfway around the circle? Okay. So if we go halfway around the circle, how does adding pi or subtracting pi affect our trig functions? Okay. So now, so I'll go blue here. Blue, if I add halfway around the circle, goes to that one. If I pick any old other point, that'd be there, and halfway around would then be over there, through the origin, straight across the circle. Okay. So, notice that 1, we're on the opposite side, because we're halfway across the circle, we're on the opposite side of the x-axis. So that would make sine be the opposite. Notice also that if we go to the other side of the circle, we're on the opposite side of the y-axis. So that would make cosine be opposite. So both cosine and sine on the opposite side of the circle are opposites. Which just means they change the SIGN sign. Not the SIN. The SIGN sign. Okay. So that would affect everything except tangent and cotangent. Okay. So these, I think, these are formulas numbers 8 and 9 right here, this E value right here. These are formulas 8 and 9 on that trig identities chart that we just hand out today.
What happened this morning? I named myself.
Good on that?
Yeah, sure.
I figured to recruit an NTC
Yes.
football recruit.
Third string quarterback.
Third string quarterback. Good? All right. So then we talked about these negative rat value things. Okay? Now, negative rat value is just a fancy way of saying we're going the opposite direction on the unit circle. So instead of going the positive counterclockwise method or direction, we're going to go the negative clockwise direction. Okay? So notice, no matter how far we go, okay, if I only went to here, we'll do this one in blue. If I go to there, that means that I'm going the negative value that way. Well, what two things do you notice? Well, let's talk, I shouldn't say what two things. Let's talk about them individually. What do you notice about cosine? It's the same, right? Because we're still on the same side of the y-axis. Okay? What do you notice about sine? Opposite, because we're going in the opposite direction. So then we came up with these two down here in D, or you came up with them, which on your, our numbers 1 and 2, yep, on your identities chart, or sheet, if you will. And that's how I think of that. Let's see what I came up with. The x values and the y values. Oh, yep. So then tangent, be going in the opposite direction. Then tangent, which should be number 3 then. Yep, look at that, number 3. 4, 5, and 6 also. Tangent would be opposite, because one of them is opposite and one of them is the same. So cosine is the same for an angle and the opposite of sine. Questions on the negative direction? Okay. So then we said, well, let's go down here. And let's say the cosine of negative 5 pi over 6, well, that's the same as the cosine at 5 pi over 6. Okay? Because of formula number 1 on your identities worksheet. Okay?
You did. You just did.
Literally. Any questions on those 3? And so then we got to the last page. And then on the last page now, we have a bunch of just examples of things to do. Okay? So I'll give you a couple minutes to figure out if you have any questions on this one, and then just ask me some questions on this one. And let's just go over particular problems.